resistance. We found out total resistance in the series combination of resistors. Okay. Now in today's video we are going to study about the parallel combination of resistors. Okay. Parallel combination of resistors. Already I told you how the resistors have been placed or connected in a parallel way. You know that will be connected in the parallel lines in that way. Okay. Now see children, first as soon as they ask you to explain the parallel combination of resistors, you are to draw the circuit. Okay. Now when you come to the circuit, what you are going to do? First, you are going to draw a battery, one positive terminal, another one is negative terminal, and a switch is there, ammeter is connected to calculate or to find out the amount of electric current. Then this is a one resistor, okay, R1, and to that R1, then we have another resistor R2, okay, and here we have R3 resistor. This first one R1, R2 and R3 resistor, okay, and again it will be connected to this ammeter. This is the way we are going to draw the circuit for parallel combination of resistor. Now see R1, R2 and R3. Here also we are going to connect a V1 for R1 and V2 for R2, V3 for R3. Okay, fine. This is the way. And electric current is going to pass from positive terminal to the negative terminal. Fine children. Now, what is the thing you have to do? Another thing you have to show. Here there is a flow of I1, I2 and I3. Okay. Fine. So, in the series combination, we had studied that the total flow of electric current, the same electric current will be passed to R1 also, R2 also, R3 also. So, I is equal to I1 is equal to I2 is equal to I3. But here what happens? You take I will be equal to I1 plus I2 plus I3. Okay. Because when the resistors are connected parallelly, there will be different electric current passing through R1, R2 and R3 resistors. Okay. So, you have to write this first condition. I is equal to I1 plus I2 plus I3. Okay. Next, coming to potential difference in the battery, the potential difference will be produced. V is equal to V1 is equal to V2 is equal to V3 in parallel combination of resistors. Potential difference will be same through R1 also, R2 also and R3 also. Okay. So this is like a vice versa of the series combination of resistors. Fine. So the next step, as we did in series combination also, we are taking the Ohm's law. Ohm's law, from the Ohm's law we derived that V is equal to I into R, right? For this I am going to substitute V1, okay, V1, first one, V1 is equal to I1 R1, V2 is equal to I2 R2 and V3 is equal to I3 R3. Now what I am going to do? I am going to take this. If I take this as first equation, second equation and this as third equation, I am going to take the first equation So before taking that first equation, here what we will do? We are substituting in this equation, no? I. So here I1 will be equal to V1 by R1. I2 will be equal to V2 by R2. I3 will be equal to V3 by R3. Alright. See now, this V1 I am writing as V only. V2 also I am writing as V only. And V3 I am writing as V itself. Because we already know V1 is equal to V2 is equal to V3. That is equal to V. Okay. Now, you take the first equation. I is equal to I1 plus I2 plus I3. Here I am going to substitute all the values. Okay, I is equal to what? I is equal to V by R, no? V by R is equal to V by R1 plus V by R2 plus V by R3. Okay, fine. Now we are going to take V as common. V by R is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. I am cancelling V and V, and we are getting 1 by Rp. Here Rp in the sense I am writing as for the total resistance in the parallel combination of resistors. Okay. So 1 by R1 plus 1 by R2 plus 1 by R3. This is how, and this is the formula to find out the total resistance in the parallel combination of resistors. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Fine children. So you should be knowing these two conditions. How much of electric current is flowing in each resistor and how much of potential difference has been applied by the circuit. Okay. So or taken by the circuit. This if you know these two correct, directly you can substitute and find out the derivation or write down the derivation. Fine.
Thank you for watching the video. Please subscribe and share with your friends.